All right, here are the video notes for lesson 1.2, and we're going to be focusing on the graphs of equations here. Some of it is kind of straightforward. I'm going to go kind of quickly through it. Some of it at the end with the tests for symmetry, I'm going to slow down and kind of really explain. Okay, just like any video notes you'll see in this class, when we have written notes portions of it, I'm going to kind of skip over that because I post the written notes. So sections with a lot of writing, I expect you to use the written notes, write those in your notebooks, and then these are just to show some of the examples and how I come up with the answers that you'll see in the written notes. So the first one here, we're determining if these points lie on the graph or not. And the way we do that is we plug in our x and we plug in our y, and we hope to see that our equation, when we plug in x, equals our y. And if it does, we say, yes, that point is on the graph. And so if I do that here, I plug in my 13 for my y, and I plug in my 2 for my x, minus 7 here, and I get 13 equals 20 minus 7, and I get 13 equals 13, which I can say, yes, that point 213 lies on my graph. We try it again in part B here, and I see that I plug in my negative 3 for my y, 10 times negative 1 minus 7, and I get negative 3 equals negative 10 minus 7. That tells me negative 3 equals negative 17, and that's a no, that point doesn't lie on the graph. So that's pretty straightforward, just plugging in your x's and your y's and seeing if they equal each other. If they do, then it lies on the graph. If they don't, it does not lie on the graph. Okay, sketching the graph of a line, a linear function, something that we should all be comfortable with here in pre-calculus. I rearrange this so I get it more into slope-intercept form. I get y equals negative 3x plus 7, so then it's y equals mx plus b. This tells me that my y-intercept is up at 7, so it crosses that y-axis at 7, and then it's this slope of negative 3 over 1, which means down 3 over 1 to the right. So I can go down 3, 1, 2, 3 over 1 to the right, down 3, 1, 2, 3 over 1 to the right, or I could even go up 3, 1 to the left. So I go 1, 2, 3 up to the left, and you can see my line forming right here. Okay, so that's linear functions. Hopefully we're comfortable with that. Now we have quadratic functions, parabola functions, and the best way to do this, because we don't really know, and you should maybe know from advanced algebra, but we may forget that we can just shift these graphs if we know them. And we will get more into the transformations of these graphs later on here in chapter 1. So if we want to start right now, what we can do is XY tables, okay? X, Y, and we can plug in our classic negative 2, negative 1, 0, 1, 2, our test points for X. I'm just choosing those points because those are going to give me a picture of this middle portion of the graph, and I can plug those in. Negative 2 squared is 4, 4 minus 2 is 2. 1 squared is 1, minus 2 is negative 1. 0 is going to be 0 minus 2, that's negative 2. Because these are parabolas, they're going to have symmetry, and then that's going to be negative 1 and 2, and you can plot these points and graph your function. Negative 2, 2, negative 1, 0, negative 2, and you have your parabola function here forming. Now, I try to draw this the best I can, but it's not going to be perfect. Same kind of thing goes for b. The only thing with b is, again, I kind of rewrite it so it's y equals negative x squared plus 5, and then your xy table is going to be based on that. Again, I'm choosing my test points to be negative 2, negative 1, 0, 1, and 2. Plugging that in. Now this has got to be kind of careful here, because what's happening here is I'm going to plug in negative 2, and I'm going to get 4, but that's really going to be a negative 4 because that negative is on the outside, okay? That negative is on the outside there. So negative 2 squared is 4. That negative on the outside makes it negative 4. Negative 4 plus 5 makes that a 1. Now you plug in negative 1. Negative 1 squared is 1. The negative that makes it negative 1 again. Negative 1 plus 5 is 4. You plug in 0. 0, negative 0 doesn't matter. 0 plus 5 is 5. Symmetry tells me that we're going to have this repeating, so this is going to be 4 and 1. So my first point is at 0, 5. And then negative 1, 4, and positive 1, 4, and then we have the last ones at negative 2, 1, and 2, 1, and you can see that my graph flipped downwards here because of the negative x squared in this function. That negative x squared is going to flip, and again, we'll see those transformations later on. Here we have our notes that you can take in the written notes, or pause this and see it here. Now we have the finding the intercepts of graphs. If I want to find the x-intercept, I need to plug in 0 for y. So I have 0 equals x cubed minus 4x. I can take out an x here, so I have 0 equals x times x squared minus 4. I can factor this x squared minus 4 here. Actually, I can leave it as it is. I can't factor this. I can leave it as it is. So I'm actually going to get two different x-intercepts here. I'm going to get x equals 0 and x squared minus 4 equals 0. And I have then x equals 0 as one of my answers for my x-intercepts. And then this one here, I need to add 4 over. So this is x squared equals 4. Square root both sides, I get x equals, and this is huge, when you take the square root yourself, when you're square rooting yourself, it becomes plus or minus 2. People forget that. So there's really 3 x-intercepts here. There's 0, there's x equals positive 2, and there's x equals negative 2. Now when I'm trying to find my y-intercepts, I'm plugging 0 in for x. So that's y equals 0 cubed minus 4 times 0. Well, 0 cubed is 0, minus 4 times 0, that's 0, so I get y equals 0 as my y-intercept. Okay, we can do this one as well. If I want to plug in, if I wanted to find my x-intercepts, that's 0 equals the square root of 2x minus 1. Square root both sides, that's 0 equals 2x, so I'm squaring both sides here to get rid of the square root, minus 1. Add 1 to both sides, that's 1 equals 2x, and this is going to tell me that the x-intercept here is 1/2. 1/2 equals x for my x-intercept. To find the y, I'm going to plug in 0 for x, so that's y equals the square root of 2 times 0 minus 1, I believe, right? 2 times 0 minus 1. Square root both sides again. Actually, not square rooting both sides, sorry. Y equals, after I actually do this, I can see it. 2 times 0 is 0 minus 1 is negative 1. And we do not do the square root of negative 1, not yet. We are not working with imaginary numbers, so there is no y-intercept because we cannot take the square root of a negative. So no solution for the y-intercept. We're not working in imaginary numbers yet. Okay. Now you could do this one here. I'm going to skip this one for the sake of time. If you have questions on it, please always reach out and ask. Now talking about symmetry. Symmetry is something I really want to focus on. Okay, because it's kind of an odd concept to test for symmetry here. All right, if we want to test if a function has x-axis symmetry, and x-axis symmetry, we'll see it here. X-axis symmetry looks like this, where if I had kind of a sideways parabola, meaning that we have the same value here as we do right here. That's that symmetry that's happening there. Y-axis symmetry would be your standard parabola looking something like this, because it is symmetrical over the y-axis. Origin symmetry looks something like this, where you would have maybe like your cubic function, where that if you spun it, you spun this bottom part down here, you spun it 180 degrees, it would land right on top of the other one. Now, how we test for this is what we can do for the x-axis is we can say, okay, let's plug in a negative y to our function. And if we plug in a negative y and it works out so that we get back a positive x and a positive y, then it's going to have symmetry with respect to the x-axis. And that goes to say that it should be the same x and y here as you have for x negative y down here, because it's the same x value, same distance to the right, but one is a positive y, one is a negative y. For symmetry with respect to the y-axis, we can plug in a negative x and a positive y, and if it comes out as a positive x and a positive y, then we can say that we have symmetry over the y-axis because the y values are the same, both positive y values, but you have one negative x value over here, one positive x value here, but you would get the same y value no matter what x you plug in. Origin symmetry, you have plugging in a negative x and a negative y, and if it comes out as a positive x and a positive y, then we know we have symmetry. And that's just related to if you have a negative x and a negative y somewhere down here, it should be the same as if you have a positive x and a positive y somewhere up here. Okay, so we'll see one right here, testing for symmetry here. We are going to plug in, first we're going to test for x-axis symmetry. X-axis symmetry means we're plugging in that negative y value. And so I get negative y equals 2x cubed. Well, there's not a whole lot I can do here. I could divide both sides by negative 1, and I would get positive y again, but this equals negative 2x cubed, and that's not the same function. We are looking for, if we plug in a negative y or a negative x or negative x and y, we're looking for this exact same function to come out, a positive y and a positive x. That didn't happen here, so there's no x-axis symmetry here. Y-axis symmetry, we are plugging in a negative x value, so it becomes positive y equals 2 times a negative x cubed. Well, negative x cubed, that's negative x times negative x times negative x. Negative x times negative x, that gives me a positive x squared, times another negative x, that gives me a negative x cubed. And so this becomes y equals a negative 2x cubed here. The negative doesn't go away because we're cubing it. This, again, this function right here is not the same as the original, so it is a no to x or y-axis symmetry. Now let's test origin symmetry. Origin, you're plugging in a negative x and a negative y. So you have negative x, negative y you're plugging in, so this would be negative y equals 2 times a negative x cubed. Well, this is still negative, oops, sorry. This is going to be negative y. We just did negative x cubed, and we got negative 2x cubed. We can divide both sides by negative 1, and you get y equals 2x cubed. This is the same as your original function, so we say yes, it does have origin symmetry in this problem. Okay? We can do another one here, and if we're going to test this, what I want to do is I want to say this is going to be negative y, I'm going to rewrite it, equals negative x squared by subtracting over the x up here. I'm going to divide both sides by negative 1, so this is really y equals x squared, and now I'm going to test it. Okay, so I wanted it to get more standard form before I test it, and then I can do my x, y, and origin symmetry again. Plugging in for x-axis is a negative y equals x squared. Well, even if I divide both sides by negative 1, I get y equals negative x squared. That's not the same function, so it is a no. Doing my y-axis symmetry, I'm plugging in a negative x, and I'm going to have y equals a negative x squared. Well, negative x squared is going to give me a positive x, because that's negative x times negative x, which is a positive x squared. And so I get y equals positive x squared again. That is the same function, so it's a yes to symmetry here. And then origin symmetry, we can do negative y, negative x, so that's negative y equals a negative x squared. Negative y equals then x squared. And then again, if I divide both sides by negative 1, I get y equals negative x squared. And again, that's not the same function, so it's a no to origin symmetry. Now, we got to practice that more. It's something that is kind of complicated for many people. And so just make sure that we ask questions if we're confused by that. And we'll talk about that maybe more in our next live meeting. Circles here, we have this equation for a circle, and that is going to be x minus h squared plus y minus k squared equals r squared. Okay? H and k are going to be your center of your circle, and r is going to be the radius of your circle there. Okay? Now, let's take a look at a problem using that. Now, we have an equation for a circle with the center at 2, negative 3, and the radius at 7. So we're going to use this formula here to plug it in. So we have x minus 2 squared, because I'm plugging in the 2 for the h. That's the h of my circle, the center of my circle, plus y minus a negative 3, that's a plus, sorry, squared equals 7 squared. This is going to be x minus 2 squared plus y plus 3 squared equals 7 squared, which is 49. And with that, I'm out of time. And